Here we have a quantity w that equals x cubed times y to the power of 4. Let's say we start sitting at the point 1, 1 on the xy plane. Over there, w equals 1. As we move away from that point, w changes. Let's say we confine ourselves to a square centering at the point 1, 1. Then, we would like to know how far we can expand the square so that the change in w is at most 0.1 in magnitude. How do we find such largest square? Here is a way to formulate the problem. Let's start with the change in w from the starting point 1, 1. We limit the absolute value of the change in w to be at most 0.1. Let's say the side of the square, centering at 1, 1, is 2a where a is positive. Then we can only move away from the center in x direction by not more than a units, either to the left or to the right. Same to the movement in y direction. With this setup, we need to find the largest possible value of a. That's absolutely a daunting task. So, let's see if we can simplify the problem using linearization to approximate the answer. Now, since we need to impose a constraint on the absolute value of the change in w, let's work on the linearization of change in w from the point 1, 1 due to a small change in x and a small change in y. So next we will compute the two first partials of w evaluated at the point 1, 1, starting with partial w partial x. We have 3 times x squared times y to the power of 4. Evaluating at the point 1, 1, the partial is 3. Now let's move on to partial w partial y, which is 4 times x cubed y cubed. Evaluating at the point 1, 1, this partial is 4. Back to the linear approximation. So we have delta w approximately equals 3 times delta x plus 4 times delta y. Alright, so far, we haven't imposed the constraint that we confine the movement to a square. That implies delta x must be identical to delta y. So then delta w becomes approximately 7 times of delta x, or delta y if you like. That means the absolute value of the change in w is approximately 7 times the absolute value of the change in x. So we have just related the change in w to the change in x. Then we know the limit on the absolute value of delta w is approximately equivalent to limiting 7 times of the absolute value of delta x to be at most 0.1. That gives the maximum allowable absolute value of the change in x, which is 1/70th. So, here is approximately the largest square we're looking for. Alright, problem solved. I hope you enjoyed this video, and I'll see you in the next one.